Imagine this. You can't outrun your shadow, but your shadow can easily outrun the speed of light. While the universe says nothing travels faster than c, your shadow is legally breaking the speed limit every time you flick your wrist, and researchers just filmed it happening at the subatomic level. Welcome to Splendidly Silly Science, where we treat the simple act of blocking a light bulb as a matter of deep cosmic controversy.
The universe is conspiring to make you think darkness is just a passive nothingness. The standard story is simple. Darkness is the absence of light, so it propagates at the speed of light, c, approximately 299 million meters per second. If the sun vanished right now, we would enjoy 8 minutes of light before darkness tragically hit us. But that is just the propagation of light extinction, the delay before the final photons arrive.
But what if I told you that you can legally break this speed limit? Imagine you have a laser pointer powerful enough to reach the moon. If you flick your wrist to sweep the beam across the lunar surface, the bright spot and the shadow bordering it will travel across the moon faster than light. Because the moon is 384,400 kilometers away, a tiny wrist rotation of a fraction of a degree sweeps the shadow at 8 times the speed of light. V equals 2.4 billion meters per second. How is that possible? It is because the shadow is not a physical object. It does not carry information or mass, so Einstein's speed limit does not apply. Consider the Lighthouse Paradox. A rotating beam from a lighthouse sweeps across a distant wall. If you place detectors along that wall, detector A flashes, and then detector B flashes in rapid succession. It looks like the spot of light, or the shadow following it, traveled from A to B at superluminal speed. But the lighthouse operator cannot use this to text a friend at the other end. No information is transmitted. The no signaling theorem holds. Each point on the screen is hit by independent radial photons. We can stretch this to the extreme. If you project a shadow onto a slanted wall, the shadow's speed is amplified by the screen's slant. If you tilt the wall close enough to parallel with the beam, the shadow stretches out and sweeps at literal infinity. Even a pedestrian walking away from a street lamp experiences this geometric amplification. As you walk, your shadow's length grows, and the head of your shadow sweeps forward at a velocity that consistently outpaces you. You are, quite literally, being outrun by your own lack of light. I know, enough with the geometry homework, because things are about to get much faster and much weirder than a walk under a street lamp. But while the lighthouse shadow is just a trick of geometry, scientists have discovered that real darkness, actual holes in light waves, can behave even more strangely. In March 2026, researchers at the Technion published a breakthrough in Nature, proving that dark points, or optical phase singularities, can physically leap faster than light. They studied optical vortices, corkscrewing light waves that cancel out completely at their exact center. Think of these like tiny dark tornadoes spinning inside a beam of light, where the light just disappears. When two of these opposite spinning dark vortices approach, they pull together and dance around each other. In the final quadrillionths of a second before they collide and annihilate, their speed diverges, leaping past the speed of light. To capture this microscopic dance of death, the researchers used a two-dimensional material called hexagonal boron nitride, or HBN. Inside HBN, light couples with atomic lattice vibrations to form Polaritons, hybrid wave packets that travel 100 times slower than light. V is approximately 0.01 c. This sluggish speed allowed the team to film the superluminal leap using an ultra-fast electron microscope with 3 femtosecond resolution. Finally, we have the ultimate cosmic darkness. Hubble's law, V equals h0d, states that space itself is expanding. Galaxies separated by more than the Hubble length recede from us faster than light, particularly at redshifts z greater than or equal to 2. This is not local motion through space, which is prohibited from exceeding c, but rather the stretching of space itself between the galaxies. Over time, this accelerating expansion will push every distant galaxy across our cosmic horizon, redshifting them into complete silence. The astronomers of the far future will look up, see one lonely island of stars, and conclude the universe is small, static, and eternal. And they will be completely, confidently wrong. Tragically, we are just the lucky ones who got to watch the show before the lights went out. Subscribing is mathematically proven to ward off cosmic dread, so tap the bell. Staring into the void is optional, but remember, stay silly.